Welcome back. Today we're going to talk about intercepts. Okay, so building on what we learned about yesterday, we talked about linear functions and graphing linear functions yesterday. Today we're going to talk about characteristics of linear functions called intercepts. Okay, so intercepts comes from the word intersection, where it's the intersection of a line with another line. All right, and there's a graph, a linear function will have an x-intercept and a y-intercept. Okay, every once in a while it'll have just an x-intercept and not a y-intercept, or just a y-intercept and not an x-intercept, and we'll talk about that in just a minute. But the definition of the x-intercept is it's the y-coordinate of the point where the line crosses the y-axis. So let's pick this out here. So first of all, this is the y-axis, and the point where this line is crossing the y-axis is right here. Okay. So let's think about this point here. This point has 0 as an x-coordinate, right? Because from the origin it doesn't go anywhere left or right, and then it has 1 as a y-coordinate. Let me just rewrite this here. So the xy coordinates is 0, 1. Okay. So the x-intercept here would just be 1. Okay, because it's just the x-coordinate. The y-coordinate is not of concern to us. It's just the y-coordinate. It's not the x-coordinate. Now, that makes sense because if you think about it, what are all the x-coordinates of the points along the y-axis? The x-coordinates are all the same coordinate, all right? The x-coordinates are all 0. So these points are all have a different y-coordinate, but the x-coordinate's always 0. So it makes sense that we're only interested in the y-coordinate because the x-coordinate has already been determined. So if I tell you the y-intercept of a line is 3, you know the line goes through the point 0, 3, for instance. Okay? Whereas the x-intercept, so now let's talk about the x-intercept. This is the point, the x-coordinate of the point where the line crosses the x-axis. Okay, well, let's look at the points here. So this point right here is -1 for x, so it's right here, and 0 for y. So again, we are just looking for the x-coordinate. So here, we're just looking at this value right here because that's the only value that can be changed along the x-axis. The y values are always the same along the x-axis, okay? So the x-intercept is the x value. So here, for our line, it's going to be -1, right? Now, another thing that I wanted to tell you before we moved on from this idea of the y-coordinates always being 0 on the x-axis and the x-coordinate always being 0 on the y-axis, another name for the y-axis, not another name, but the equation for the y-axis is the line x is equal to 0. So yesterday we talked about the idea that x is equal to a number was a vertical line, right? And so when x is equal to 0, it's the vertical line that we call the y-axis, right? In the x-axis, the equation for the x-axis, it's a horizontal line where the y value of that line is always 0. And again, we talked about yesterday that y is equal to a certain number or a constant was a horizontal line. So the horizontal line of the x-axis has the equation y is equal to 0. And that's why these coordinates are only interested in the values that are not 0. So for the x-intercept, it's the x-coordinate, and for the y-intercept, it's the y-coordinate. Okay. When you have a graph, it's very easy to determine the x and y intercepts. So here's the x-intercept and here's the y-intercept. So the x-intercept is going to be the x value, so it's -10, and the y-intercept is going to be the y value where it crosses, which is -5. So again, these points are 0, -5 and -10, 0. So you should be able to work back and forth. If they give you the x-intercept, that implies that it goes through the point the x-intercept, 0, and likewise with the y-intercept. All right, so when you have a graph, it's very easy to determine this, except when you have a vertical or a horizontal line. So let's talk about that for a minute. Let's draw a vertical line. So here, let's draw this vertical line, and let me just go ahead and draw a horizontal line so we can use that in just a second. Okay, so the vertical line that we just drew was right here. So remember, this is the vertical line. It's 10 units to the right of the y-axis, so that's called x is equal to 10. Okay. Now, this line is the one exception to the rule that every line has an x and a y-intercept. Every diagonal line has an x and a y-intercept, but if you have a vertical line or horizontal line, then it will only have one or the other, but not both. So in our case, the x-intercept is 10 because x is equal to 10, all right? And there's no y-intercept. Okay. In this case, this is the line, let me put this a different color. This is the line of y is equal to 8. So in this case, the y-intercept equals 8, and there's no x-intercept. Okay. This is very different from having an x and a y-intercept of 0. Okay, so if we have a line that's graphed through the origin, like this line right here, okay, let's say that we have this line right here. This line is goes through the origin, right? So let's put the arrowheads on it. This has an x and a y-intercept of 0. 0 is a value in our system here. So 0 has a position. So it has an x-int of 0, and it also has a y-intercept of 0. That is a very different idea of saying no x-intercept and no y-intercept. This is a coordinate. When you say that it has an x-intercept of 0, you're indicating that it has a coordinate value, that it exists in our two-dimensional system. Whereas when you say there's no x-intercept, that means that it literally just does not cross the x-axis. Okay, that there's no point in our coordinate system where this horizontal line crosses the x-axis. So be very careful of those ideas, because we often associate the number 0 with the idea of none. But in this case, it's not the same thing. 0, 0 is a coordinate in our two-dimensional system, whereas there's literally no way that this horizontal line can cross the x-axis, nor this vertical line cannot cross the y-axis. Okay, so those are very different concepts when we're dealing with graphing. Okay, finding the intercepts from an equation. Now, it's very easy when the equation is in standard form like we see here. And again, this equation is in standard form because if you recall, standard form is ax plus by is equal to 12. Now, I know that this is a plus here, but we could very easily do this. So now your a is equal to 3, your b is equal to -2, and your c is equal to 12. So I just use keep, change in order to change the subtraction into addition to match the standard form here, and then b becomes a negative integer, which is okay because b can be any real number, which includes negative integers. Okay, so this is in standard form. Find the intercepts from an equation in standard form is fairly easy, actually, because what you're looking for is, now remember, the x-intercept is the x value when the line crosses the x-axis. Okay, so what you know when the line crosses the x-axis, like we saw before, when the line crosses the x-axis, the y is always 0. So really what you're looking for in terms of an equation is you're looking for the x value when y is equal to 0. Okay, so to find the x-intercept, what you're going to do is take this equation, 3x plus -2 y equals 12, and you're going to set y equal to 0. So here, let's solve this equation too. Okay, this just gets 3x plus, this ends up being 0, so it's just 0 is equal to 12. So 3x is equal to 12, x is equal to 4. So this is the x-intercept is equal to 4. Okay, now likewise with the y-intercept. The y-intercept is the y value where the line crosses the y-axis. So here, this was our original x, the line that we were dealing with originally. Well, what happens when the line crosses the y-axis? The x value is 0. So it's the it's the y value when the x value is 0. So all you have to do in this equation is set the x equal to 0 and then solve for y. So it'd be -2y, because that gets 0, is equal to 12, divide by -2, y is equal to -6. So our x-intercept, our y-intercept is equal to 6. And let me just write this out a little bit neater. Okay, so we have our x-intercept and we have our, oh, this is -6. We have our x-intercept and we have our y-intercept, okay? So what we're gonna take, we can do with that is, this is the same equation that I had before. It's actually easy to graph with the intercepts, right? Because these indicate 2 points in the line. This is the point 4, 0, and this is the point 0, -6, right? So I can take those points and very easily translate them to a graph to plot graph the line. It's a little bit easier than graphing with a solution table. So let's see, we want an x-intercept of 4, so that's where it crosses the x-axis, and a y-intercept of -6. Here are 2 points. Those 2 points, between any 2 points, a unique line can be formed, meaning given any 2 points, there's only one line that goes through these 2 points. So I can very easily just go ahead and graph the line. So here we have the line of 3x minus 2y is equal to 12. And we talked yesterday about the idea that the solution table is one way to graph an equation, but it's not the most efficient way. So this is a better way of sort of graphing the equation, is using the x and y intercepts of a linear function in order to plot those and then draw the line through them. Okay? All right, here's a word problem. So it's important, if you have a word problem, to be able to understand what the x and y intercepts are in terms of the word problem. So the Sandia Peak Tramway in Albuquerque, New Mexico, travels a distance of about 4,500 meters to the top of the Sandia Peak. It travels at a speed of 300 meters per minute. Okay, so every minute it travels 300 meters. All right, that's the distance along the line that it's traveling. The function f of x is equal to 4,500 minus 300x. Okay, so this looks like it's the top of the mountain here, right? Because every minute you're going to multiply the x by 300 and then subtract it from the vertical, the top of the Sandia Peak. Okay, so the tram's distance in meters from the top of the peak is the f of x, and the x is the minutes. Okay, find the intercepts. Okay, well, when we find the intercepts here, first of all, we can find the y-intercept by setting the x equal to 0. So here, what I'm looking for is f of 0, and this is going to be my y-intercept, because it's the value of y when f is 0. Notice I'm putting 0 in as the input here. So f of 0 is equal to 4,500 minus 300 times 0. So f of 0 is equal to 4,500. Okay, so it looks like actually this tram is going down, right? Because it's making a descent, because it starts at 4,500. So at time 0, it starts at 4,500, and that's actually what we're doing for the second part here. So f of 0 equals 4,500 means, and I'm not going to write it all out here, means that at time 0, the tram was 4,500 meters above the ground. Okay. Now, to find the x-intercept, what we're looking for is the value of x that makes the function 0. So notice this is the x-intercept. What I'm doing here is I'm making the output equal to 0. Okay, or the y, this is equivalent to making y equal to 0. This right here is equivalent to making x equals 0. Well, if you do that and you solve for it, you would have 0 is equal to 4,500 minus 300 times x. So here, let's subtract this from both sides. We'd have negative 4,500 is equal to negative 300x. So let's divide each side by 300. Okay, and over here we have x left. Here, let's cancel some of these zeros. So we have just negative 45 divided by negative 3 is 15. Okay, so our y-intercept is equal to 15. All right. Now remember, that's our x value and the y value is 0. So our x-intercept is equal to 15 means it's 15 minutes. Okay. Well, what does that mean in the context of the problem? So interpretation of the intercepts means take these numbers that you just got, 15 and 4,500 and interpret them into the context of the problem. So figure out what do they mean in the context of the problem. This is one step beyond just finding out what they are. It's going back and looking about what this means. So in this case, what this means is when y is equal to 0, it means that it has a height of 0. Well, if it starts way at the top of this peak, a height of 0 would indicate that it reached the bottom. So this means that the tram takes 15 minutes to go from the top of the peak to the bottom of the peak. Okay? So that's what you mean. That's what we mean by interpret the intercepts. What do they mean? Find them, and then tell me what they mean in the context of the problem. Okay, so we talked all about intercepts today, x and y. We talked about how to find them with a graph, how to find them with an equation, and what they mean in the context of the problem, and how to use them to graph. All right, and that's the end of the lesson for today.